Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Eighth graders, it's Monday. Welcome back. So, a little short period today because you find out about the testing, right? And then Wednesday is a half day, so it's going to be a fast week. So, look forward to that. Also, no test this week. So, anyway, always possible for a pop quiz though. So, you want to make sure you be triple R'ing big time, okay? So, you've got a white sheet. I'm going to have you write a few things down on your white sheet on one side, and then you're going to in a little video I'm going to show you, you're going to put some bullet facts down. Okay? So, anyway, I've got a little homework for you already. I want to make the point on this already. This is our basic physics textbook. So you were supposed to already have it here in your locker. You will need it tomorrow. So, forces and energy, basic physics. So, if you will make sure you've got that here tomorrow in class, great. Hey, on your test, this particular test, this person just missed 1 out of 60. So, looking good. I wanted to go over just a few of the points that seem to be a little bit stickier for people. The smallest part of a compound, that's a molecule. The smallest part of an element's an atom. That's different. Smallest part of a compound is a molecule. What chemical process taking place on the sun? Hydrogen turned into helium and heat and light. Fusion, of course. Atomic packing, that's density. Density, how tight the atoms are packed. All of this will be on your final. So, one example of a group of subatomic particles known as quarks. Well, they're the ones in the nucleus, protons and neutrons. Right, second page, radioactive elements, number 1 characteristic. They spontaneously break apart, or they're very unstable. So those are the major characteristics. The particles that are released when radioactivity occurs, when a radioactive element decays, besides gamma radiation, alpha and beta particles. Which of those particles is the most dangerous to living tissues? Either gamma rays, so that'll work. Gamma rays, electrons are dangerous as well. Let's see, besides treating disease, how is radioactivity useful? Like at Palo Verde Nuclear Generating Station to make electricity. I gave it away. Generating station. It generates electricity. Valence electrons have the highest energy level. Valence electrons, highest energy level. The arrangement of an atom's electrons determines its chemical properties, what it's like, in other words. Let's see, if an atom has 8 valence electrons, it is very stable, or the most stable. Lots of this metal are found in Arizona, great conductor of heat and electricity, big clue right there. Copper, Cu, copper. Very strong but light metal used in human knee and hip replacements. Titanium, Ti, titanium. So anyway, okay, you have your white sheet out. I want to ask you a few questions about proteins really quick. You saw Hank talk to you about proteins, and then you also saw Dr. Meyer talk to you about proteins. So on your white sheet, just a few questions. So, what are the building blocks of proteins? Number 1, what are the building blocks of proteins? By the way, in your next test, I'll focus on proteins, and then on our topic this week, which is forces. So anyway, Proteins are made of what? You've got about 20,000 different proteins in your body and 80,000 to 400,000 estimated proteins total. Okay, number 2. About how many of those building blocks, your answer number 1, are there? About how many different building blocks? It's why you can get 20,000 different ones. Number 3. The shortest protein that we're aware of in the human body. So the smallest one, it's the one that forms hemoglobin, the red blood cell chemical that picks up oxygen. 147, and then all the way up to 34,000. Wow. So my question number 3, because of the exact arrangement of those building blocks, you get the just right number of those building blocks, and then 2 other things that have to be just right. You just need to do one of them. Besides just right number, anywhere from 147 to 34,000, and you can't have any missing, or it doesn't work in the human body. So just right number, and then there's a couple of other just right possibilities. For number 3, put down one of them. And then number 4, I told you about a disease, a blood disease, where the hemoglobin molecule is misformed because of one of the building blocks being substituted by another one of the 147. I want you to draw the shape of an abnormal red blood cell that has this disease. So draw the shape of one of these blood cells, and then I'll show you one in just a minute. Okay? And then proteins do a whole bunch of different jobs in your body, all the way from they repair tissues that are damaged, they reproduce tissues where the cells are dying, they've got to be replaced right away, they help break down food that you eat into chemicals that your body can use. They do all kinds of just right jobs in just the right place at just the right time. Those are called enzymes. They communicate between organs and cells, so communication is involved. So they give you a strong immune system. They're involved in your immune system, and the parts of your immune system that recognize and attack and kill foreign objects in your body, bacteria, viruses, other things too. So they're involved with the immune system, and then they're involved in giving different parts of your body structure, the way they're built. That's the job of proteins. Proteins basically do all the major jobs in your body. No wonder we have to have 20,000 different ones and 80,000 to 400,000 total. Okay, on your white sheet, here are your answers. Number 1. What are the building blocks of proteins? I like to call them double A's, amino acids. Amino acids. Good idea that this goes in your journal. The building blocks of proteins, double A's, amino acids. Mr. Phillip is noticing you writing all of this, these few things actually, in your journal. What are the 20 different building blocks of proteins? Amino acids. There's 20 different ones. 20 different amino acids. Well, how can you get so many different ones? Because you can have a different number. I gave you that part. What else? It's the location, where you've got a just right location for each amino acid. And then it's got to have just the right folding, so it can do just the right job in just the right place. So there's so many just rights that prove that God made proteins. So just right number of amino acids, I gave you that. Just the right location of the amino acids, just the right folding of the amino acids to do just the right job in just the right place. So, and then number 4, what's the name of that disease? It's called sickle cell anemia, and the sickle cells look like this. They have that shape. Instead of being this shape, instead of being oval shaped or round, they have this shape. And they can't do their job right. And it's the difference that just one amino acid makes. So, don't you love the way God specified the number, location, and total number of amino acids to do just the right job in just the right place? All specified. It is such a massively big deal. It's just huge. So, and then I wanted to show you this. Dr. Meyer said that the chance for just one protein of 150 amino acids, that's a modest protein. It's not a big one, it's a small one. The chance for one 150 amino acid protein to form by itself, like evolution, by evolution. Here it is. The mathematical probability. One chance to form a good protein that does good jobs. One chance, that's 10 to the 164th. That is this number. 10, or 1 with 164 zeros behind it. Just one chance. One chance out of that number. I have no clue what that number is. Now, because of that one chance, that equals 0. Now, if someone says, well, there's one chance. I know, let's say this was the chance of you passing my 8th grade science class. You have one chance over, that's the numerator, over the denominator of 1 with 164 zeros behind it. Is it going to happen? It's not going to happen in a bazillion lifetimes. It's just, it's so small a probability. So, and then I wanted to show you this. Dr. Meyer made this point. It's coming. Here's what he said. Because of the probability, no serious scientist thinks that life began by chance. So again, when you're in high school or college, and if you have a secular science teacher, and they go, oh, life evolved, just remember Dr. Meyer and his quote, because he's telling the truth. No serious, who's really serious about science, not make-believe science, not magic, which isn't science. Because that number, 1 over 10 to the 164th, that's magic. That's not science. There's no way it could happen. No serious scientist thinks life began by chance. And they think the same thing about DNA, because DNA makes every kind of life. It's got to be formed by DNA. So you just remember the mathematical probabilities and the complexity level of DNA. And you'll go, didn't happen. So you've got some homework tonight. I want you to read and highlight LS13. Mr. Phillip will pass this out to you. LS13. Just read and highlight it. That's what you need to do. And look over your protein information. You never know when you're going to have a pop quiz. So, LS13, and read and highlight it. Now, so you're going to look at that. I'm going to show you a video now by probably the greatest physicist who ever lived. He lived in the 1600s. It was English. Maybe he's like one of a handful of the most brilliant scientists who ever lived. He has his laws of motion and his universal law of gravitation, which we'll be getting soon. So anyway, who was he? On your white sheet, write down who you think it was. Who do you think it was? That's it. Sir, because he was, I think it's because he was knighted maybe, Sir Isaac Newton. Newton's laws. Newton's universal law of gravitation. You're going to watch a short, very short, 4-minute biography about the highlights of his life, and really quick write down a few bullet facts about his life, the major things on the back side of your white sheet, name, date, and period. Then you're going to hand it in at the end of this period. So on your white sheet, and you need at least half a dozen key bullet facts about Isaac Newton's life. And here we go with that video. Mr. Phillip.